All right, this is section 3.2, and today we're going to be talking about parallel lines and then the types of angles they create. We kind of did some of these words yesterday, and they do something a little different when the lines are parallel. So if we go to our theorem card, we're going to be talking about those big four, our corresponding angles, alternate interior, alternate exterior, and consecutive interior. And then in the next column, we kind of have like the words, like how would the definition read? And then I'm going to draw you a picture down here, and then we're going to talk about what does that mean to us mathematically. What are we going to be able to do mathematically in order to solve some problems? So the first one reads, if two parallel lines are cut by a transversal. So I'm going to draw two parallel lines. I'm going to put triangles on them so we know that they're parallel. Now I'm going to cut them with a transversal. And then it says, then the corresponding angles are equal. So yesterday, or in the previous lesson, we talked about corresponding angles. They look like this. So they're on the same side of the transversal, but one on each parallel line. And it just means that they are equal to each other if the lines are parallel. So we should be able to say somewhere for the problem that we're about to do that an angle equals an angle. This angle is equal to this one. For alternate interior angles, I'm going to draw you two more parallel lines, and I'm just going to tilt my parallel lines each time just so you kind of see a different picture every time so they don't all look the same. So here are my parallel lines. My alternate interior angles look like this. They're on the inside of the parallel lines between them and then on opposite sides of the transversal. And AIA angles, or alternate interior angles, are also equal when the lines are parallel. So we're going to be able to say that some angle equals another angle. Alternate exterior angles. Here are my parallel lines. I'll do some vertical ones this time. I'm going to cut with a transversal. These are the ones that are parallel. And my alternate exteriors, that would be that one and that one, kind of the farthest away you can get angles. They are also equal, only if, again, the lines are parallel. So we will be able to say that some angle is equal to another angle. The last ones are the ones that are the oddball out. So supplementary is how this last pair end up. So if I have two parallel lines and they are cut by a transversal, then the consecutive interior angles, the ones that are cozy, the ones that are right next to each other, they add up to 180. They are supplementary. So we're going to be able to say that angle plus angle equals 180, kind of like P plus P equals your whole amount. So those are four different types of angles and what they do when you have parallel lines to begin with. So now let's go to the notes and we'll do a couple. So this first one, I kind of want to identify what kind of angles they are. So I'm just going to look at all four kinds that I have. I'm going to just put a little arc mark kind of in the corner so I can just have a visual to match it up. They're not right next to each other like co-interior. They're not opposite corners like this one, like that would have to be there and there, like way diagonal from each other. These guys are inside the parallel lines, and I got one that's outside, so that's not going to work. So they are corresponding. I've got same side of the transversal and then one on each parallel line. And those are set up to be angle equals angle. So I'm able to go 23x minus 5 equals 21x plus 5. I'll move my x's first. We move the smaller x always, so we'll move the 21 over. That'll leave me two x's with the minus 5. Then I'll add 5 to the other side. 2x equals 10. Divide by 2 and I get 5. Next picture, I'm just always going back to my blue card to figure out what kind of angles they are first. So first up I've got this kind, the corresponding. That doesn't quite look like this. I'm going to do those little arc marks so I kind of have a little reference. That does not look like that. It does look like this one. They're kind of diagonal like this. They kind of almost make a Z shape right there. And these do the same thing. So that little Z right there. So that means I've got an angle equals another angle. So we've got 60 equals 8x minus 4. I'm going to add 4 to both sides. So I'm going to have 64 equals 8x. And then divide both sides by 8. And I will get 8 for an answer. Last one, I'm going to do those arc marks again, kind of give me some perspective, just sneak it in there, that's a minus 1. Those do not look like this. We're not on Same side of the transversal, but on the other side of that parallel line. They don't have that Z look to them. These ones actually have a C look, and that matches these ones. So these also have kind of a C look to them, kind of a backwards C. So this one says that it's angle plus angle equals 180. Whoops. So 20x plus 5 plus 24x minus 1 equals 180. So we'll do our like terms first. So I've got 44x's, and then 5 minus 1 is plus 4, so 180. We'll minus 4 from both sides, so we'll have 180 minus 4 for 176. And then we're going to divide both sides by 44, and we're going to get 4. Next up, based on our parallel lines, we should be able to essentially get one measure and then fill in all of our other measures based on all those different types of angles we've done. So if angle 9 right here equals 80 degrees and angle 5 is 68, we should actually be able to figure out every single other angle in this picture. So first I'm going to look where my parallel lines are. So those two parallel lines, and I can only look at one transversal at a time. So I'm actually just going to cover up, looking for a blank piece of paper. I don't have one. Here we go. I'm actually going to cover up this part. I only get to use the parallel lines and one transversal at a time. So I'm just covering up the other transversal so I don't see it. To go from this angle to this one would be 80 degrees. Those are vertical, so those are equal. And then next two angles, these adjacent angles that make a straight line, they are supplementary. So this angle will then be 100, which makes this one 100 because they are vertical as well. Since these lines are parallel, this 80 can jump all the way over here for corresponding, or that 80 could have gone here for alternate interior, which makes that 100 go here and right here. I'm going to do the same thing on the bottom angles. I'm just going to cover up the top part so we don't see all that. These are still my parallel ones. Whoops, arrow goes the other way. And Q is now my transversal. So if that's 68, this has to be 68. And then if I do 180 minus 68, that will give me my other two angles, which are going to be 112. And then I can jump those over to the other side. So this is just going to get copied, 68 for 68, 112, another 68, and another 112. And then I can answer every question I have here. So the measure of angle 12 is 100. Measure of angle 1 is 80. Measure of angle 4 is 100. Measure of angle 3 is 80. Measure of angle 7 is 68. And measure of angle 16 is 112. Last one, we've got more of an involved picture we're trying to solve for. I see the triangles, that means these lines are parallel, so I'm going to extend those lines a little bit. Sometimes it's easier to see the parallel or the transversal when we extend those out a bit. And then this is my first transversal I'm going to work with, so I'm going to draw that line right there. And then these two angles right here, if I look at my card, they kind of make that C shape. So these are co-interior angles. So that means that 5x plus, and we know a box is worth 90, have to equal 180. So I'm going to subtract that 90 over, and then I'm going to divide by 5, and I get 18. Then I'm going to draw this other transversal, so kind of coming down like this. And this is arrowed in here so that this whole thing belongs right there. So don't think it's right there. So these two are also co-interior. They kind of make that weird C looking shape, which means that I'm going to be able to add those and equal 180 as well. So I'm going to distribute first. And then I'm going to add like terms. So 5y plus 4y, and then 55 minus 10. So I'm going to take 180 and I'm going to subtract 45 from it. And then we're going to divide it by 9. 15. So using those same names that we had yesterday of those 4 big types of angles, and then today we're just talking about if we have parallel lines, then what is the interesting thing we can use in order to solve?